Alright, this video is for the special segments in triangles notes. This is lesson 2.5. So we're going to go over a little bit of vocabulary about these special segments, and then we're going to look at a diagram and actually draw these special segments. Alright, so we're going to start with the altitude. So the altitude of a triangle is a line segment drawn from any vertex, vertex of a triangle perpendicular to the opposite side. Okay, so from any point, and it's got to be perpendicular to the opposite side. So perpendicular to the side and then go through that point. The median of a triangle is a line segment drawn from any vertex of a triangle to the midpoint of the opposite side. Okay, so this one has to be the middle of this side and then go through that vertex. This one doesn't have to necessarily fall in the middle of that side, it just has to be perpendicular. The mid segment of a triangle is a line segment drawn from the midpoints of two sides of the triangle Okay. And so I just want to show you something, these little marks, what these mean. So you can see here the little squares in there. That means it's perpendicular. It's forming a right angle. These two little marks here mean this length equals this length, meaning this point is in the center. So same thing here. See, we've got two hashes here and two hashes here. That means these two segments are congruent. So we know that point is in the middle. And then perpendicular bisector of a side of a triangle is a line segment perpendicular to a side of a triangle at the midpoint of that side. Okay, so now it's going to go through the midpoint, but it's also going to be perpendicular. These aren't perpendicular. They go through the middle, but they're not perpendicular. These are. All right, so we're going to draw the altitude of ABC from point A. Label this segment AD. So we have to find, if we're going to draw it from A, we have to draw, or we have to know what, we have to be perpendicular to BC. Okay, so if we look here, BC is a horizontal line on the coordinate plane. That means AD, okay, the altitude has to be perpendicular, meaning it has to be straight up and down. So it's got to follow that little hash mark. And so that would be point D, okay? Their slopes are negative reciprocals, okay? All right, draw the median of ABC from point B. So remember, a median is going to go through point B, and it's going to hit the midpoint of AC. So I have to find the midpoint of AC. All right, so to do that, let's see here. I've got another piece of paper here so I can show my work. So for the midpoint, we're going to use the x's. So my x values are 7 and 13. 7 plus 13 over 2. And then the y values. So I've got 10 and 2. 10 plus 2 over 2. So I've got 20 over 2 gives me a 10. 10 plus 2 is 12 over 2 gives me a 6. So at 10 comma 6, 10, 6, that's the center. Okay, that's the midpoint. And so to draw it from point B, I just connect those two dots. Okay, if you don't have a straight edge, just do your best to get you a pretty good straight line going in there. That's point E. All right, draw the mid-segment of ABC using the midpoints of AC and AB. So we've already done AC. Now we need to find the midpoint of AB. Okay, so AB, let's see, our x's are 1 and 7, so 1 plus 7. And then y values are 2 and 10. So we've got 8 over 2 is 4, 12 over 2 is 6, 4 comma 6. 4 comma 6, there's the midpoint. Okay, so the mid segment is going to connect, so that's point F, the midpoints of two sides. So that's the mid segment, or one of the mid segments of the triangle. And it says draw the perpendicular bisector of side AB. Okay. We've got to find the slope of AB. I can count this slope out, okay? So we're going up 1, 2, 3, 4, 5, 6, 7, 8. We're going up 8 over 1, 2, 3, 4, 5, 6 over 6, which is going to give me 4/3. The slope that's going to be perpendicular to that, negative reciprocal. So we flip the fraction on its head, change the sign. And it says label that segment FH. So, sorry guys. So remember, the perpendicular bisector is going to go through that midpoint. So we can start at that point. That's why we're labeling it FH. And we can actually count out the slope. Go down 3 over 4. 2, 3, 1, 2, 3, 4. Do it again. 1, 2, 3, 1, 2, 3, 4. And again, connect the dots. Okay. And that's point H. Okay. So here's the thing with this. Eyeballing it, and that's why we prove it mathematically. FH may not look perpendicular, this one, because I know to my eyeballs, this doesn't look like it's perpendicular to this, but mathematically it is, and that's what matters in these. So that's it for this set of notes.